Hey, how's it going? So I'm still making this baseball game, and where we are with this baseball game is just about at the end of what I can do with just one dimension. So I've already got this guy throwing the ball, I've got another guy hitting the ball, or I'm hitting the ball with the space bar, and you know, I've got one force on the ball, and that's air resistance. I just talked about putting air resistance in here. So now that we've got air resistance in here, what I want to do is I want to go ahead and start introducing two-dimensional things. So I'm going to update the update function so that it will handle y coordinates, and I will also modify the batter's swing so that when he hits it, the deflection is now going to be at an angle. All right, and this is one of the things that we introduce in two-dimensional physics. It's actually the first thing, is that when you have a reflection at an angle, you have to worry about tangential and normal vectors. So if you have a bat, right, that's more or less vertical, then the tangential vector is just along the bat, and the normal vector is perpendicular to the bat. And it's only this normal direction that deflects, right? So the velocity of the ball that's parallel to the bat will not change. That's how we're going to model this. This isn't the best model for a bat, but it's going to be good enough for what we do, and it's going to introduce some of the concepts that we use in class. So that's what this particular game is for, is to introduce concepts in class, not to perfectly model a baseball game. So what I'll do is I'll go ahead and try to introduce that in the next 13 minutes. So the first thing is just to start working on that deflection, right? So that deflection would happen with this reflects, right? But I don't really like that reflects. I think I'll do a reflects off. I'm just going, I could modify reflects, but I'd like to just make a brand new method for this. I'll probably want to do a reflects, a more simple reflects thing, keep that in here for bouncing off of the ground, because as you'll see in just a moment, we have a problem with the ground. So what we're going to have to do is the same sort of thing, right? We're going to send the position back to its old position, so old x. But we're going to have to do it in both the x and the y directions, right? Old y. But you see we have a problem here, is that we're not storing that old x in the update, or old y in the update. So we'll have to store that up here as well. And while we're doing that, both of these guys, they need to be duplicated, right, in the y direction. Actually, everything has to be duplicated in the y direction. So self y is going to increment in the same way as self x did. The y coordinate will increment in the same way, and forces will affect the y velocity in the same way that they affect the x velocity, and independently. And yes, we have to clear out the y force as well. Hopefully that'll be sufficient to get everything running. So now we have everything that we need for this guy. What we're going to have to do is get some stuff from the thing. So the thing is the bat, and it's actually going to send the batter to this position. So what I'm going to do is I'm going to want the x position of the batter. So x will be the thing dot get position, and I really only want the 0th component. So you can index your function call there, unless you really want that y component. I don't really want it. And I need a width, and I've made a get height function that I didn't show you here. A method, excuse me, in the batter. I'm sorry if that confuses you, but you know, I just wanted to get it done. It's not something that's anything new. Get and set functions you should be fine with. You can make one on your own time if you're following along. And I divide it by 3 because, like I said, approximately 1/3 of your height is in your shoulders, right? If 1/3 for an arm, 1/3 for a shoulder, 1/3 in an arm. So your width basically is 1/3 of your height, more or less, right? All right. So what do we do from here? So now what we want to do is we want to find the angle, right, that we're hitting at. And we could do that by some complicated method based on when we hit the space bar or something like that. But instead, I'm just going to use the position, right? I'm going to say that the position on the screen is relative to, or is related to that angle. So I'm going to take the difference between, so this angle is going to be proportional to the distance between x, the position of the batter, and what's that other thing? The position of the ball, right? And I think I'm going to go ahead and add the width of the guy in there because it's at about the shoulder where his bat is, right? It's at about his shoulder when it's completely vertical. Now we're using vertical even though there are a lot of other issues here, right? Usually you're just hitting the ball on a bat, but I just want to use this as a way to get an angle in there based on your input. All right, and then we'll have to do something with math pi to get it in angles and then divide by 4.0. So actually that's pretty close. I probably don't even need to do that. But we can use that angle and that'll give us something reasonable. Again, I probably didn't need to use pi over 4 because that's just a little bit over 3/4. Now what do we do? Okay, so now I've got that. Now I want to calculate those vectors, right? So I'll go with the normal because I want, when the thing's completely vertical, when it's right at this position here, I want that to be at about, let's say, I want that to be horizontal, right? Which means that I know that the normal component should be the cosine of this angle, right? Because that angle should be 0, and so I want the normal to be 1 in the normal direction, and I want it to be 0 in the perpendicular direction, and that's minus math sine angle. You could use plus, but then all the angles would be reversed from what we see when the thing shoots off. All right. So I also need the tangential vectors, and the tangential vectors are something like this. Tx is going to be equal to ny, and ty, the y component of the tangential vector, is equal to minus the x component of the normal vector. This is all fairly rudimentary. It's all in the lecture that I probably haven't put up right now, but will probably be there when you look at this by the time a actual class is being run. Hopefully by the end of summer, but that I can't promise. So now I've got those two tangential vectors and the normal vectors. I want to save the tangential components of the velocity, and I want to reverse the normal components. Okay, which means I have to find the normal components and the tangential components, right? I have to find them before I can manipulate them. So the normal component of my velocity is the velocity dotted into the unit normal vector, and the components of the unit normal vector are nx and ny. So that's self.vx, the x component of the velocity, times the x component of the unit normal, plus self.vy times, so the y component of the velocity, times ny, which is the y component of the unit normal. And we do the same thing for the tangential component of the velocity. You have vx times now the x component of the tangent, plus self.vy times the y component of the tangent. And you know, I could have not done this assignment of the tx and the ty. That would have been perfectly acceptable. I think it's a little clearer, at least for somebody who's getting used to these ideas, to actually make that assignment. It might actually be useful for other reasons, but it's not strictly necessary. It all goes away after the reflex off method is finished, so it's not really important. So now I've got these two guys. What do I need to do? I need to go back to self Vx. So I need to come back here to the x component of the velocity. So now that's going to be the normal component of the velocity times the x component of the normal plus the tangential component of the, or I should reverse that, minus Vn, plus the tangential component of the velocity times the x component of the tangent, unit tangent. So it's still a very simple procedure. All I'm doing is adding vectors vectorially, right? This is not something that's going to win you any awards or anything like that. It's basic sort of stuff, right? So I want however much of the normal component is in the y direction plus however much of the tangential component is in the y direction. That's all those are saying. So that should give me something simple there. Now, I'm not really done yet, right? Because I haven't told the computer to run this reflex off. So, versus that reflex. So, when I come down here, I have my engine where I call that thing. Where is Mr. Engine? Way down here. Control, View, Engine. I probably should do this in a more reasonable way. So here's where I was reflecting. Now I'm going to reflect off the batter. So now that's calling it. Now I can see all of my errors. All right. Hopefully they are few. Hopefully I got all my signs right. Hopefully I can figure out how to hit that. I think I hit that. Okay, so you may have seen that I hit that, and I hit that one, it goes down, hit that one, it goes up. I'd like to beam the picture. That would be nice, but I seem to be hitting a lot of foul balls. Oh, that one was better. Oh, that's getting better. Worse. Okay, you don't really want to see me sitting here playing the game, although it seems to be working reasonably well. Not as well as I probably would hope. Let's see if I can fix that a little bit by changing this W. I think this will be closer to where I actually put the response in the thing, so maybe that'll work out a little bit better. Again, all this only works if I can hit it. Okay. I liked it better earlier. Yeah. Okay, so that was working better. So I think that more or less got it. I think I'll tinker around in the guts of this thing to try to make it work a little bit better before I get on to the next video. But that's just going to be playing around with the detection algorithm in the batter and this reflects off function. Again, I'm hacking most of this in, and I thought I had a reasonably good looking deal for this when I hacked it in just a little bit earlier, and you know, it's doing what I want it to do. It's just not hitting at the exact. It's not hitting enough angles right at the picture for me right now. I'll play with that, get something working, and then I'll add in gravity in the next one. All right, or maybe probably I'll add in bouncing off the ground after I get a reasonable amount of bouncing in the first place. All right, so I'll see you pretty soon, I hope. All right, bye now.